Hey folks, welcome to Mobile DevOps Summit. This session is iOS widget screenshot automation. My name is Alexander Botkin. I'm a senior mobile engineering manager at ChargePoint. I manage the iOS and Android teams here, which build the apps for ChargePoint for iOS, Android, as well as CarPlay, Android Auto, Android Automotive OS, as well as our smartwatch apps on watchOS and Wear OS. I'm joined today by Rishabh Sukumar, who is one of our senior iOS software engineers, and Monica Gorkani, who is one of our senior staff iOS software engineers. And with that, let's go ahead and get started. First up, I do want to mention in the bottom right corner of each slide, you may see a QR code. When this QR code comes up, you can open up the iOS camera app, point your camera at the QR code and tap the yellow banner if you want to learn more. We will use these QR codes to link you to useful resources, additional documentation that might help you to get a better understanding of the concepts that we talked about, or to kind of help follow up on some of the things that we've learned along the way. So with that, the first question I'm sure you're all asking yourselves is, why automate screenshots? And there's a few different reasons that we have at ChargePoint for why we automate screenshots. The first reason is that App Store Connect keeps having changing screenshot requirements. As you are all aware, Apple has recently released the iPhone 14 Pro, and with it, the dynamic island is now available. But this also now means all your App Store screenshots will need to update soon to show the new fancy dynamic island. Right now, Apple has it as an optional requirement, but as Apple has done in past years, this will become a required screenshot within the next year. And the question you should ask yourselves is, should developers or marketing really be making these screenshots one-off every year when you have new devices? Or wouldn't it be easier to have some automation that would create these screenshots for you so that you can just say, hey, launch up the iPhone 14 Pro simulator and get me the screenshots? Another reason that we automate screenshots at ChargePoint is to get a visual baseline for review and comparison. So at ChargePoint, our app that we provide on iOS and Android helps electric vehicle drivers to find charging stations. And once they get to the charging station, it helps them to pay for their session and track their charging session costs as well as energy throughout the session. So in this example, you can see we have the screenshot from the ChargePoint app of charging activity. And in this page, users are able to see their past charging sessions as well as current charging sessions. And we try and help them get an understanding of how much they've spent on EV charging within the last month, how much energy they've added, and so forth. So in the screenshot comparison, you can see that a developer has made a change. And due to this change, we can now see that the cost calculations for public and home charging at the top for the month are now showing cents, while previously they did not show cents. And so this could now get flagged onto a pull request, and someone could ask the question, hey, developer, did you mean to do this? Was this a product requirement, or was this a regression that just slipped through due to an edge case? With automated screenshots, you'd be able to have that conversation and not wait until QA notices it right before your release. Another reason we use automated screenshots at ChargePoint is it helps us to guide development of UI changes. How often do you have a new software engineer or a new UX designer coming onto the project who is not familiar with all the different edge cases of a particular UI flow? Like your payment screen, for example, may have several different scenarios between personal and business cases. And it might be a bit much to have these developers and designers having to figure it out on the way. So with automated screenshots, you can automate every screenshot within the app and then be able to provide them with a simple guide of here are the screenshots related to your feature to help them get a basic understanding of what's going on, as well as help you kind of decide if you want to reflow things easily. And the most important reason for why we automate screenshots here at ChargePoint is to empower our developers to move faster. As you can see in the screenshot, we have an example that we will talk about later in the session where we use / commands in order to trigger automated screenshots in different device sizes, different device languages, as well as light mode, dark mode, and a few other configurations as well. And the reason we've created this is it helps our developers to move faster so that when marketing comes to them with a request of, hey, we need the screenshots in Korean for a new ad that we're going to do, we're able to just kick off a build from Slack and be able to grab those screenshots and send them over to marketing without someone having to do this work manually. This is very important for us to kind of help keep developers happy, as well as have our developers be able to leverage these tools to have better code overall. And with that, I'd like to bring this over to Rashab, who will kind of walk us through how do we actually automate screenshots.
Thanks, Alex. So we have now spoken about why we need to automate screenshots. Let's now dive into the technicals of how we set up, write, and execute UI tests to create these screenshots. So to start writing UI tests in Xcode, you need to first create a UI testing bundle target. You can do this by going to File, New Target, and adding your UI testing bundle target. This will look like the screenshot you see on your right. Well, Xcode then generates a UI test.swift file with an XC test case subclass. And once all the setup is complete, you just need to add test functions that save attachments onto the XC test case, which are then available to you through the xcresult. Let's look at an example function where we take a screenshot of our target application called Chargy. This particular example method is called test main view screenshot, and we will use this to grab a screenshot of our main map view in the Chargy app. The first line of this test case calls XCUIApplication to create a proxy for our target application. We then use this app proxy to launch the Chargy app. Once we're in the app, we look for our map view using its accessibility identifier. We then wait for about 3 seconds to make sure this view exists. And once we are sure that this view exists, we then go ahead and grab a screenshot of our visible screen. We name an attachment, and then we specify a lifetime, and we attach this screenshot to our test case. Here, one thing to note is that we specified a lifetime for keep always. This is particularly important for the course of this presentation because we always want our attachments to be available to us after the tests are completed successfully. It is possible with Xcode and xcresult to specify that screenshots be deleted after test run successfully, but we don't want this behavior, which is why we specify a lifetime for always. You may have noticed that the code used to create your screenshots and attach them to your test case can be made generic. So we've gone ahead and created an extension for XC test case and created a method called save screenshot. With this method, developers can simply give a name to the save screenshot method to name their screenshot, and then run the same code that we did in the previous slide. So this makes our test cases a whole lot simpler, as you'll see through the course of this presentation. On this slide, we can now see that our test main view screenshot method is a whole lot simpler and easier to read now that we have our save screenshot helper method. Finally, once your test runs successfully, you'll be able to see your test in Xcode via the editor and open your screenshots to view your particular use case. In this case, we do see our main map view for the Chargy app, and you'll see a few different chargers in the San Francisco area. So what exactly is XCUIApplication doing? As discussed earlier, XCUIApplication is a proxy for a specified process that allows you to send events like launch, monitor, and terminate in a UI test. You can use this proxy to find and interact with visible elements as well. XCUIApplication isn't limited to just your target application. You can use it to create a specific proxy for any process using the process's bundle ID. Here is an example of using XCUIApplication to create a proxy for the native settings app with the bundle ID com.apple.preferences. We will see how powerful XCUIApplication is and the number of use cases it offers to developers in the following slides. Let's take, for example, a development team that wants to take screenshots of their app settings bundle. In this particular UI test open app settings, we use XCUIApplication to create an app proxy for the native settings app using its bundle ID com.apple.preferences. We then call the activate method on this app proxy to launch our settings app. Once we're in the settings app, we can swipe down until the Chargy app is visible, tap into it, and once we're in the Chargy app settings, we can take a screenshot. As we have seen with the settings app, you can use, you see the screenshot in front of you. Well, as you can see with settings app, you can use XCUIApplication to access a number of apps using their bundle IDs. And some other useful examples of this may be apps like Safari and Shortcuts, for which the bundle IDs are com.apple.mobile Safari and com.apple.shortcuts. Bundle IDs for installed apps on your device and simulator can also be found using the xcrun simcuddle list apps and device UUID command. Additionally, for those interested, the QR code on this slide will take you to an Apple site with a list of bundle IDs for all the native iOS applications. Xcode allows developers to attach to processes for debugging by navigating to debug and attach to process in Xcode. And some of the processes you may have seen there include Springboard, Posterboard, and the Workflow UI widget configuration extension. XCUIApplication also allows you to access any of the processes you see in this debug menu as long as you have its bundle ID. We will see how these particular processes can be used in a number of ways to enable more powerful UI tests. One of the processes we did mention here was Springboard. Springboard is the process that manages the iOS home screen. And creating a proxy for Springboard using XCUIApplication allows developers to do a number of things, such as access your notification center, get to Spotlight search, navigate to your Today view, and add home screen widgets. We will see how we can write UI tests to achieve a few of these cases. Now, let's look at this UI test to take a screenshot of notifications sent from the Charge app. We will first launch the Charge app using XCUIApplication. Once we're in the app, we tap on the zoom button to zoom to San Francisco. We then create a proxy for the Springboard app using its bundle identifier. Once we have the Springboard app proxy, we will then call the activate method to get to our home screen. Once we're in the home screen, we can use Springboard to get specific coordinates for the top of our home screen. Once we have these coordinates, we can press and drag to get to our lock screen. Finally, once we've reached our lock screen, we can see that we have received our charging notification and we can save a screenshot. The following slide will show you a few screenshots of this charging notification in multiple language configurations. The ones that we have set up in our Charge app are for German and Korean. Another powerful use case of Springboard is navigating to the Today view and adding a Today widget. With this particular test case, we will look to get to our Today view firstly, and then add our Charge app's Today widget. First, as you've seen with the previous slides, we're going to be creating a Springboard proxy. We will use that to get to our home screen once again. Now with Springboard, we will swipe to the right a couple of times to reach our Today view. You may have noticed that this springboard.swipe method isn't typical for how you would swipe with XCUI tests. To make our code simpler, we have created an extension for XCUIApplication to then add a swipe method where we can specify direction and a number of swipes. So once we've reached our Today view, we're then going to look for the edit button on our screen. We would swipe up to get to the edit button, and once it's visible and we're sure that it exists, we will tap on it to get to the customization view. Once we're here, we will then swipe up once again to get to our customize button for our Today widgets. Once we are in the customized view, we're going to look to add our Today widget by searching for the label Today widget, which is the name for our sample apps widget. We will then tap on this to add our Today widget and hit done to exit our customization views. Now that we know that our Today widget is visible, we're going to swipe up, get to the widget, and grab a screenshot. The following slide will show you a screenshot of our Today widget once the test is completed successfully. Yet another powerful use case of Springboard is to add widgets on our iOS home screen. So you will see with this particular test case that we're going to be adding a couple of Charge home screen widgets in the small and medium sizes. This particular test case has an argument called isMedium_size so that we can specify which widget we want to actually add. So yet again, with this test case, we're going to be creating a proxy for the Springboard app, using that to get to our home screen. Once we're there, we can press and hold to customize our home screen. Once we're customizing our home screen, we can look to add a widget. Once we're found our Charge widget, we can then go ahead and add it. For our medium-sized widget, we check for the particular argument. And if it is true, then we will swipe to get to the medium-sized widget and add it as well. Once we've added both our widgets and know that they exist, we then grab a screenshot of our home screen. The following slide will show you a couple of screenshots in different languages for our home screen widgets in the small and medium size. What's interesting about these screenshots of a widget is that it has some text that asks you to do something additional in addition to adding these widgets. So we're asked to edit the configuration to explore location. We do know that widgets can be made configurable, but how do we configure widgets in a UI test? Well, this is not as simple as it may have seemed, because editing a widget configuration is not easily done via Springboard. This is because elements of the widget configuration are not visible to Springboard while you're running your UI test. To resolve this issue, we look for the Workflow UI widget configuration extension process. We use its bundle ID to create a proxy for this process, and that then allows us to edit our widget configuration. As you can see on the right, our ChargePoint configuration simply asks us to enter a particular location, and we will use this to write further UI tests on upcoming slides. But before that, one interesting thing to note is that the Workflow UI private framework contains a few other extensions as well. These include the Add Shortcut extension, the Catalyst Content extension, and the Focus Configuration extension. Now that we've discussed the process that will enable us to edit our widgets, let's look at a test case where we will edit the home screen widget that we added in the previous test. With the edit home screen widget UI test case, we're first going to use Springboard once again to get to our home screen, customize our home screen, and then tap on our widget to edit. Once we've reached the widget configuration view, we're going to create a proxy for the widget configuration extension process, grab a screenshot of the widget in its configuration view. Once we've done that, we're then going to tap on the location property, search for a particular city, in this case is Cupertino. And once we specify that, we're going to tap multiple buttons to dismiss our editing views to get back to our home screen to see our newly configured medium-sized widget. The following slide will show you what our medium-sized widget looks like when fully configured with the location Cupertino. You will see that we have a list of nearby chargers for the Chargy app. The following slide will show you a few other configurations of our widget once fully configured. So this is in dark mode and in the German language. Now, we know that with iOS 16, there were a few changes made to widgets and what's possible. So with iOS 16, we are now able to customize our lock screen. Particularly, users can change their lock screen font and text color, they can change their wallpaper, and they can add lock screen widgets. Adding lock screen widgets is not simply possible using Springboard or the widget configuration extension. Instead, there's a whole new process called Posterboard, which handles customization of the lock screen. The bundle ID for Posterboard is com.apple.posterboard, as you see in the slide above. And we will use this process to write UI tests to actually add our Chargy lock screen widgets, edit them, and delete them if so required. So the following slide will show you a test case where we look to add lock screen widgets. So once again, we'll see that Springboard is particularly powerful for developers because we're going to use this to get to our home screen and access our lock screen as we saw with notifications UI test. Once we are in our lock screen, we're going to navigate through a few customization views using Springboard. And once we are in our customization view for the lock screen, we're going to create a proxy for the Posterboard process. Once that is done, we can look to press the Add Buttons collection cell in the lock screen. Once we've done that, we can search for the Chargy app particularly. And once we've done that, we can go ahead and dismiss our editing views and see that our lock screen has been added. Lock screen widget has been added. Well, the following slide will show you that if we went through the process of adding a lock screen widget and configuring it, as we saw in the previous test case for the home screen widgets, you will see our Chargy lock screen widgets in multiple configurations. So here you'll see, one screenshot of the Chargy widget when it's not configured, one when it has been configured, and one when it's been configured in the Korean language. So we've seen how we can use XCUIApplication to attach to app processes like Springboard, Posterboard, and the widget configuration extension. But what if we want to invoke Siri shortcuts? Well, this is not as easily done using XCUIApplication. Instead, we will go ahead and use XCUIDevice for this case. Well, XCUIDevice is a proxy that is used to simulate physical buttons, device orientation, and Siri interaction. The XCUI device shared instance has a Siri service property, which represents the device's Siri interface. This Siri service property is an instance of the XCUI Siri service class, which has a method called activate, in which you can pass some input text to Siri. What's particularly neat about this method is that you can pass strings that are localized as well. And this should invoke Siri in that particular language as long as the device's Siri input language setting is set to the particular localized language. So let's see how we can use XCUI device and XCUI Siri service to write a UI test to invoke one of Chargie's app shortcuts. So here, yet again, we're going to use Springboard to get to our home screen. And once we've done that, we're going to call XCUI device.shared.SiriService.activate and pass the invocation run sample with Chargie to invoke our Chargie app shortcut. Once we see that our Siri response has been displayed on the screen, we're going to grab a screenshot and we'll have our successful test run. We'll have our test run successfully with our screenshot available to us. So we've seen that we can use processes and XCUI device and XCUI application to write a number of UI tests and grab screenshots of multiple different configurations, not just of your target application, but also on your home screen and your lock screen. Now, what if we want to write tests and gather them in different configurations, such as different languages, different locations, different UI interface styles? So with Xcode, we can make one test plan and add a number of configurations to it. These configurations, as mentioned earlier, can be used to specify a particular app language and region. It can be used to specify whether you want to keep screenshots once the test is run successfully or not. Well, one thing to note with this is that any language settings that you make in your test plan configuration only apply to your target application. So with test cases that we saw for the home screen or the lock screen or with Siri, you will need to actually change the device's language settings, which can't be done through the test configuration. We'll see how this can be done in your CI pipeline in upcoming slides. One other neat thing that you can do with Xcode is add a GPX file to simulate a custom GPS coordinate or route in your test cases. Now, how do we actually run these test plans and configurations without going through Xcode? And if you want to use it in our CI pipelines? Well, we can use the xcode build command. The xcode build command can be passed options such as test plan to run one particular test plan, such as screenshots, or we can pass the only test configuration option to run a specific configuration for a test plan. In our case with the Chargie app, we've set up one test plan called screenshots, which has multiple configurations for English, German, and Korean. We use this to run all of the UI tests you've seen in this presentation in different languages and different configurations. If you're working with the Bitrise Xcode test step, these options can be passed to the Xcode build command by adding them in the Xcode build configuration section of the Xcode test step. Now we've seen how we can write UI tests and create our screenshots, as you can see in front of you with an xcresult that you can edit, navigate through in Xcode and open those screenshots. But what if you want to get all the screenshots for your test plan at once? Well, xcresults are not the easiest things to parse and extract screenshots from. With xcresults, you'll see that if you navigate through Finder, you have one big folder that's not easily navigable. And so Apple does provide developers with a tool called xcresulttool to parse and extract attachments coverage from your xcresult files. But this is not a one-line extractor. It takes a bit of work to get to it. As you can see here, we have about 4 commands that we're using to get the screenshot you see on your right. We first run the xcresult tool to get to a JSON. We then pass a certain file ID, then use that ID to get to additional JSONs. And it's just a whole lot of nesting to get through until you reach your screenshots. How can we make this simpler? Well, to make this simpler, we at ChargePoint wrote a Swift command line tool called xcparse. xcparse can be used to extract screenshots, attachments, logs, and code coverage from your xcresults. And this can all be done using one command. So for the case where we've written UI tests for Chargie, we can use the xcparse screenshots command to grab all the screenshots for a particular test plan. Additionally, we can pass options to xcparse to separate these screenshots by model, OS, language, etc. Bitrise also has an xcparse step, and this can be used in your workflows to extract screenshots and code coverage and send those directly to your Bitrise deploy folder for easy access. So we've seen that we can write UI tests for multiple different use cases. We can even extract the screenshots all at once. But what if you want to integrate this with your CI platform, such as Bitrise? Well, I'm going to hand off to Monica to walk you through this process.
Thanks, Rashad. So why would we want to integrate with Bitrise? So what's our goal here? By integrating with a CI system like Bitrise, we can actually make it really easy for any developer on the team to launch a customized screenshot build. For instance, in this case, I'm showing you a Slack command where we have a command for doing a build on Bitrise, and anyone on the team, it's me here, I run the build for the screenshot workflow and pass the branch that I'm interested in and the language that I want the test to run. And the build will just happen on Bitrise. And when it's ready and done, I will get the update and the result for it. So how do we go ahead and customize these kind of builds? What do we need to set up? Environment variables are kind of the key to make sure that we can customize what test plan we want to run, what configuration device, what interface style. All that can happen by just using one workflow that can do all the work. The workflow will have some default values for these environment variables. So if you just run the workflow, it will do it for default settings. But then you can actually change those environment variables if you want a different language, you want to run it on dark mode. And one very important step in the workflow is to take any argument that you get as part of, for instance, the slash command or curl call for doing a Bitrise build, and taking those arguments and translating them to the environment variables that you want to set. So in this example, we actually have a step where it takes all these arguments, which are could map to device language, specific device, whatever. And then we're actually setting up the environment with that specific language. So we started with default value, but now we can update those default values. So one important thing is, as Rashab also mentioned, that when we have those test plan configurations for different languages, that only affects your app. But there are times when we want the entire device to be set to a specific language. That itself can become another step in your Bitrise workflow, where given whatever was the environment setting for the device region, we can actually use plist buddy and set up the language for that specific device. And that makes it very easy to basically run that device in any other language besides the default English one. As you know, with Bitrise stacks for Xcode, we will get a set of predefined simulators that are available in that stack. And actually, if we run the Bitrise test, if we specify a different simulator, that will also be enabled by Bitrise. But there are times, as we mentioned, we would want to actually run our simulator on a specific language or in a specific setting like dark mode. And for that, it actually means that we have to first, if there's a simulator that's not included in the default Bitrise stack, to actually create that simulator device version by calling simctl-create and then passing the specific simulator version that we want. And once we do that, and that's yet another step in the workflow, we can have that particular simulator ready, and then we can set up the language for that simulator and then run our test. And that makes it really powerful that there are times when we would want to test, all these screenshots for a different build, a different simulator version than the one that came with the latest, to make sure that those screenshots still look okay. Here's an example that besides the language, we also want to control the appearance of the device. And there is another command line, simctl command that we can use, where we can actually pass the device and specify the appearance. So for these examples, we can actually have, for instance, a dark mode version that we want to run for our screenshots to make sure that the screenshots that we're getting are in dark mode. And again, it's really easy to just apply, call this command as one of your steps in Bitrise and have the test run with that particular appearance. So one of the powerful things about being able to use a CI system like Bitrise is that you can actually do customization to make it really easy to have anyone in your team just run those builds without actually going to Bitrise, to the website, and actually running it manually. An easy way to run, to create Slack commands is to actually create an app in Slack. And in this case, we have a Bitrise demo app that we're going to set up for a specific workspace on Slack. And then we're going to set up the Slack command using the outgoing webhook from Bitrise. So once you set up, you create the app, then there's a setting for actually create slash commands. And in that edit settings, you can go and actually set up the name of your command. And there's a request URL, which is the outgoing webhook from Bitrise, which I will show just later how you can get that. And then basically, once that slash command is set, you just need to call it and pass a predefined message with the syntax that's specified by Bitrise, which allows you to specify workflows, branches, and environment settings. And that makes it, again, really easy to run a build and have it be for specific workflow and branch. Now, with regards to that webhook, you can go on Bitrise and go to your app settings. And there's an integration section, as you see on the left side. And when you select that integrations and scroll down, there's a whole outgoing webhooks configuration. And in this case, you just have to select the add webhook, and there's one for Slack. There's also another one for GitHub, but you use the Slack one, and then you actually get a URL that you can use as part of your slash command setup. And then that makes it really easy to be able to just have your slash command communicate with Bitrise. Here's a sample Slack command. So you can see, I ran the Bitrise build Slack command that I showed you that I created. And I used the syntax that Bitrise expects, which includes the workflow, the branch, and you can set up any set of environment variables. In this case, I'm using the environment variable that we set up for the iOS device language. And this is the argument variable. And we had a step that would take this argument and then convert it to an actual Bitrise environment setting that we have in our workflow. Now that we've gone through how these things can be set up with Bitrise, it is time to actually get our hands dirty and actually create a Bitrise app using the sample widget screenshot automation app that we've made available in our GitHub. So you can go to this URL or use the QR code, and I will show you in the next few minutes how you can actually create an app and see how you can set up these steps for a screenshot workflow and run all the tests that we shared with you in this presentation.